This is a GCSE AQA chemistry question. It's from the Trilogy 2019 paper, and it's a higher tier question. Covers quite a lot of different topics: rates of reaction, crude oil, and reversible reactions. I'm going to recommend that you have a look at the question and try it first, pausing as you go, and then review. So we're going to start with parts A and B, followed by parts C and D. Then we have part E. And finally, we have part F, and there are 13 marks available in total. So if we take a look at part A, hydrocarbon C10H22 is cracked and we make two substances. So complete the equation for the reaction. Well, C10 to C7 means that I've got 3 carbons left, and I've got 22 hydrogens here, only 16 here, which means I've got 6 hydrogens, C3H6, which is propene. Now, you can also think on this on a slightly different way, that we know in cracking we will always produce an alkene, and we've just proven that here. We can be confident that that is the right answer. Part B, explain why the hydrocarbon C7H16 has a lower boiling point than C10H22. Well, it's a smaller molecule. And because it's a smaller molecule, it means that there are weaker intermolecular forces between the C7H16s compared to the C10H22s. And if the intermolecular forces are weaker, less energy needs to be put in to overcome them. On to part C. Explain why changing pressure affects the percentage yield of ethanol. Well, the first thing I'm going to do is look at the ratio of moles. I've got 2 moles of reactants and 1 mole of products. Increasing pressure will increase the yield. It will give us more ethanol. And it will do that because increasing pressure will favour the forward reaction, because increasing pressure favours the reaction that leads to a reduction in the number of moles. So the equilibrium shifts to the right, hence, going back to the beginning, more ethanol. For part D, the forward reaction is exothermic. How does figure 1 provide evidence for this? Well, let's take a look. At 300 degrees C, we get a much greater yield than we do at 500 degrees C. So, decreasing temperature increases yield. We know that decreasing temperature will always favour the endothermic reaction, because that will oppose the decrease in temperature. Moving on to part E, we have got a catalyst being used in the reaction to produce ethanol. Complete figure 2 to show how the catalyst increases the rate of this reaction. So there's quite a lot to draw on here. You need to draw your first energy or reaction profile diagram. This is reactants, this is products, and we have got the activation energy, the energy you need to put in for the reaction to go ahead. But then we need to show what happens if we add a catalyst. And with a catalyzed reaction, the activation energy is lower. So we have a lower hump, a lower activation energy, but the energy of reactants and the product remains unchanged. And finally, on part F, suggest why the catalyst does not affect the yield of ethanol at equilibrium. Well, a catalyst will increase the rate of forward and reverse reactions by an equal amount. So if both rates increase by an equal amount, we don't change the position of equilibrium, but we reach equilibrium faster. And that takes us to the end of that question.